Want to welcome you to the second session of our 2020 Fall Webinar Series. Today, we will be covering a mini course in mechanical engineering. We will hear from an engineer from Lockheed on how to learn from your successes and failures. Then Joel Pitts from the Greenville solar car team will talk you through how to find parts and then introduce you to a bit of what they're doing at Greenville. So we're glad that you're here, and let us get started. Okay, I'm going to cover today just a very brief section on construction and materials technology. It's really meant to be an introduction to help you prepare to build your first solar car. And so we'll talk through a few items, particularly what materials you may use, how to construct your roll bar, your roll cage, and your crush zones. We'll do a very brief introduction on suspension and steering. We expect that we'll have a more detailed session in the spring on that. And then we'll talk a bit about wheels and brakes. With regard to the material for the frame, we do have a set of materials that solar cars typically use. The very first type would be mild or carbon steel. It's the cheapest form of material that you can find out there that is structural. When I first started building a solar car, that's what we used because it was easy to build. They come in square tubes, so it's very easy to fit against one another. It's very easy to work with. You essentially weld it with some type of wire-fed MIG welding, so you can learn that as you go along pretty easily. The downside of that is, of course, it's very heavy. And so, you know, we always suggest that when you first start building or thinking about building, you consider doing some mock-up of the PVC or something like that, is some cheaper material to start to just sort of mock up your structure, right? But anyway, when you first start building, you want to go and do more of a mild carbon steel that's, you know, fairly heavy. We always say we can overbuild. The picture that you see on there is from a car that Walnut Solar Car built in 2005, and it was called El Tanque del Sol because it weighed almost a ton. Not where you want to be in terms of weight, but it was structural, it kept running, and that's really what you want in a first car. A lot of teams actually move towards chromoly steel, and really the difference between the two is the weight of it, right? I mean, it is more expensive to do that, but you know, you can MIG weld chromoly just like you can MIG weld a mild steel, and it is lightweight. And so if you're trying to build something and you have the resources to do so, chromoly steel is really a way to go in terms of getting the structural integrity that you want and still keeping things lightweight. A third option for you is aluminum. And we started moving away from steel towards aluminum when we built some of our other cars. It's very stiff. So, you know, there's in steel, there's a bit of flex. Aluminum doesn't do that. It's really stiff. And so you sort of have to brace things appropriately such that, you know, the tube doesn't shear. It is harder to weld, meaning that you use TIG welding as a method of welding that material. And of course, that takes a little bit more, let's say, dexterity because it's not a wire-fed type of welding. It's more of a sort of similar to stick welding type of thing where you have to use two hands to go and work on things. The other sort of interesting thing about aluminum is that it's generally in circular tubes, right? You don't see like square type of aluminum tubes. And that makes it hard for when you need to weld things together to mate the two tubes together. One thing that we have done when we work with aluminum tubes is that we would notch it with a hole saw so that it would get a tubular frame, tubular cutout on the end of the tube, so that when you put it against another tube, you get a very nice contact point between the two tubes, and that'll give you the ability to weld that very closely. So something to consider if you're using aluminum to go ahead and plan for doing something like that. But I think it's a very neat material to work with. It's very light, and that helps you in terms of your design. Finally, you have carbon fiber or composite material. And this is sort of for more advanced type of cars, or if you have already experience working in that. It is the lightest and stiffest material. You essentially lay in fiberglass and Kevlar and things like that into sheets, and it gives that nice structure with it being very thin and very light. So it is difficult to do because there's a lot of processes involved. Typically, what you would want to do is to make a mold of what you're building, and then you sort of lay the layers of that carbon fiber material alternating between material types to get the material that you want on top of that, and then you have to vacuum bag it. I would say that if you're interested in this, there are many of teams that are working with that, and so you can ask questions there. Plus, there is a introductory video showing how New York made their carbon fiber body on our website and on our YouTube channel, so take a look at that. One of the things you have to consider here is a lot of people build a shell using the carbon fiber, and then they might build a structural metal frame, within for the roll cage and roll bar to sort of have that structural integrity in the middle, and then some framing on the outside. If you choose to do carbon fiber for that material, you can certainly do that as well. You would just simply need to have appropriate panels throughout the different sections to give you that structural integrity, and then you would need to have a professional engineer go and certify that it is sufficiently structural. So something to consider there. Okay, so that's just a brief look at the types of materials you might want to use. I want to spend the next few minutes talking about the roll cage, the crush zone, and the roll bar. It's one of the key things that you have to consider when you're designing the car. The way this works is we are recommending, or we are requiring 3 different types of structure to protect the driver. You have an interior roll cage that provides the rigid protection encompassing the entire driver. And there are certain minimum requirements in terms of the frame material, the frame dimensions that you must have. But the idea is that that's your last point of defense. So in case of an impact, you need to have essentially a really strong frame around the driver so that they don't get hurt. Outside of that roll cage, you want to have a crush zone area. And those are things that are designed to collapse on impact and take the energy from an impact away from the driver, right? There are requirements with regard to the distance away so that you have some spacing between you and the impact point. And then there's some minimum coverage as well in terms of it's got to cover the driver area. And then finally, the roll bar is a key piece of the protection mechanism because you have to have a very strong piece of metal that's above the driver in case the car flips over. You have all the weight of the car resting on that roll bar. So we're looking for some pretty hefty strength metal there that's continuous so that there's no separate weld points that might be of issue. And then with minimum wall thickness. So that's sort of the rules requiring it. Let's talk through sort of some examples of the types of roll bar and roll cage and the like. So when you look at the roll bar, you have a one continuous piece of metal that's right there that goes above the driver's head. You got to make sure that there is sufficient clearance from the top of the head to the roll bar, and especially as you seat your various driver heights or really torso heights in the your driver may have different torso heights that might affect that, and so you want to make sure that your roll bar sufficiently accommodates all your different drivers with the appropriate level of clearance between the two. The other thing to consider is attachment points. And you'll see in the side view here that there are an attachment that goes back, and then there are also attachments on the side on the frame. And we are requiring that you have multiple points of attachment because you don't want a roll bar to sort of fail one direction to the other. You got to have some type of brace so that it doesn't go forward or back. Usually, it's not going to have any issues going laterally, but forward or back is really where you have the issue. So roll bar is actually a fairly simple example, but crush zone is where we really get into issues with solar cars. Again, going back to what we want to do with a crush zone, the crush zone is designed to absorb impact and to protect the driver from front, side, and rear collision. So we have different zones to consider: front, side, and rear. Side, of course, is most likely and the most concerning to us because of the distance from the side to the driver. And when you submit your registration material and your drawings, you're going to have to show us what your crush zone is. But let's talk about crush zone design, right? We say that the crush zone must have structural frame members that are encompassed throughout the entire driver area. And so this is sort of a frame for the roll cage, and then there would be some crush zone material to the outside of that sort of reflects that. Now let's take a look at more detail. This is an example of the Iron Lion's car where it's sort of a neat design where you have fairly thin metal that's on the outside of the car. And you can see that they designed that so that it can collapse, right? Certainly there are other framing materials there as well, but you put a lot of thin stuff on the outside, that'll take a lot of impact and take that force away, right? And then you have a very thick roll cage right next to the driver that, if someone were to get hit there, you're just not going to have any issues there with impact because, it's going to stop anything that comes back there. and then you have the roll bar that goes on top of them. So this is a good example of how they considered what a crush zone is versus what a roll cage is. Another example that you'll see here is in this car, they have a very strong roll cage around them, like most cars do, but their crush zone is essentially just another piece of metal. Now, a lot of cars will need to do that because they've got to frame their solar array on their car, so that's fine. But you know, if you're going to have some crush zone structure, you really want to have some thinner material that can take the impact and move that away from the driver. So that's certainly something to consider. If you have questions about any of this, feel free and put that in the Q&A or the chat, and I can go back to it. But I'll also move on to the next set of material, which is suspension and steering. So the common suspension types that you're going to see in solar cars are a McPherson strut, which is essentially a single A-arm with a shock that goes up and mounts to the frame of the car. And that allows you to have some type of movement. It's a fairly simple thing to attach. One of the considerations there with a McPherson strut is there is going to be some type of angling because you only have one sort of axis point that moves. And so when the suspension engages, you're going to get some type of movement of angle there. Going back to the crush zone, I got a question with regard to, should we use the same material for the crush zone as the rest of the frame? I would suggest that you would use the same material in terms of the type of material, primarily for attachment reasons, right? So if you are building in steel and you decide, okay, I have a steel frame, and then you decide, I'm going to put aluminum as a crush zone, then you got to figure out, okay, so how am I going to attach that crush zone structure to the frame, right? You can't weld it because it's dissimilar materials. So instead, you would have to make attachment plates and sort of bolt them together. That gets messy. So it's not a requirement that you use the same material, but it certainly is a lot easier. Okay, getting back to the suspension types, certainly there are some, primarily in cars themselves, you have a solid axle that can sort of have some spring. Those are sort of springs on top of that axle that's there. And that provides a bit of shock without doing anything major there in terms of having to have some springs and the like. And then finally, you have the dual A-arm, which is a fairly common style of suspension where you have two attachment points. And so when the suspension engages, your wheel goes completely vertical up and down, and that gets you some benefits. Okay, I'm gonna go through my animations. So other considerations that you have, when you think about suspension and steering, you gotta look and say, okay, so what is the contact patch of the tire on the ground? So this is really a consideration on the type of shock that you want to have. How springy do you want? But if you think about it, ideally, you'll see a spot that's like just a tiny circle when you look down on the ground, your wheel would have a fairly small patch, and that really lowers your friction. But that's not real in terms of as you weigh down the car and as you have some level of suspension. The less suspension you have, and the more the car weighs down onto the ground, you will see a larger patch. So you want to size your suspension springing essentially to sort of minimize the amount of contact patch that you have on the ground. Likewise, for steering, there is a steering axis that you have to consider. That's a pivot point between the wheels. And when we get more into details in a future session on suspension and steering, you'll see how that affects the steering geometry. I will introduce to you a bit of steering geometry terminology that as you start designing things, you want to look up, right? So the 4 key terms is toe, caster, camber, and scrub radius. So toe is simply you have 2 wheels and you have, as you turn, how much of the wheel is angling more or less away from the center line of the vehicle. Essentially what you want is as you turn, you want the inner wheel to turn more than the outer wheel, right? Or else it'll sort of start dragging and skipping along, and that'll be inefficient. So we'll talk through how you actually get the right toe. There is also caster and camber, which are sort of the other dimensions of when your wheels are vertical, you'll move and have some type of angle because your suspension won't be exactly vertical. You may have forward or back type of angling. You might have different displacement on the axes. So certainly when we talk about details of steering, we will talk through how to optimize that. And then the scrub radius is just the distance of the steering angle and the contact patch of the tire. So just how much of your tire gets on the ground. When we design steering, one of the things that you want to do is there's this concept of Ackerman steering where you want your tires all to point to the center of the turning circle in order to minimize the amount of drag that's on the tire, right? If you think about a car that if you're going fast, you start hearing a bit of screeching as you go around a corner. That's your tire sort of not following the angle of the turn to the point of which it does a little bit of a drag skip effect, right? And so in solar cars, you really want to have the least amount of drag or friction as you drive your car, and some of that is really with regard to the steering. What we suggest is in your design of a car, you want to get your turning circle set to a distance of the at most of the turning radius required, which is, I believe, 25 meters, but check the rules. And so you want to certainly put that a little further in so that you have some leeway. You don't want to be at the exact turning radius. But once you set that point and you then lay out the dimensions of your car and where the tires go, you'll want to start drawing lines from that center of the turning circle to your outside, to each of your tires, and then you would then set your tires at that angle. From there, then you straighten your tire out, and then you see that there's a certain angle of your tie rods that aim essentially to the center of the back axle, right? And that will get you to be going straight when you're going straight. When you want to go straight, all your tires will be pointing and angled correctly. And then when you turn, they'll all follow the radius of the turn. So that's the concept of Ackerman steering. So as you design your car, certainly consider that. Finally, let's talk about wheels and brakes. There's a lot of different parts that you can get for wheels. It's sort of difficult because once you, there's a lot of considerations in terms of what type of wheel, and if you start going to more of the optimum wheel selections, it's kind of hard to purchase. And Joel will talk a bit about sourcing materials in the second half of this webinar. The other thing is your wheel needs to be designed fairly on the design process. Why? Because the wheel attaches to your hub, which attaches to all the steering and suspension. And so you're going to have to deal with that early on. Plus, it sort of determines the size of your car, right? Or your size of the car also determines where your wheels are placed and its design. One of the things you have to consider when you first build a solar car is, do you want to go 3 wheels or 4? In a 3-wheel design, we require a reverse trike configuration where you have 2 wheels up front, 1 wheel in the back. Of course, in a 3-wheel design compared to a 4-wheel design, it is lighter because you have 1 less wheel, right? It's less expensive. It's easier to align in the sense of you only have those front wheels to deal with because they're the steering wheels. So everything you just have to do once. But it is not as safe in the sense of if you have a blown out tire, if you have a flat tire as you race, then you're essentially down to 2 wheels, and it makes keeping in control a lot more difficult. If you go with a 4-wheel design, you still have those 3 wheels to help you. Having said that, a lot of solar cars do use a 3-wheel design for its simplicity, and it hasn't been too much of an issue. It's just something to consider. I would say that when I was racing in '97 and we had a 3-wheel design, we had an issue testing on the road where the kingpin of the front left steering wheel, due to vibrations on the road, had actually come off, and we didn't put in an appropriate cotter pin on that to secure it, and it came off, and the car just basically tipped right on the road and fell down, right? And so that's the consideration that you have to have with a 3-wheel design, is that, you know, something that happens like that means that you have to quickly get out of your cars, you set cones, you know, there's a lot of considerations there. On a 4-wheel design, of course, you know, more parts, higher cost. You have to align both sets of wheels. But the benefit to a 4-wheel design is you spread out your weight distribution, right? We didn't talk about weight distribution on the 3-wheel, but if you have a single back wheel that has all your motor and controller connections there, it gets fairly heavy in the back. And then, you know, you're trying to distribute that weight throughout your car so that your wheels are carrying the same amount of weight is more difficult to do in a 3 and the 4-wheel. And the benefit of distributing the weight is that each wheel then can take less weight, which means that you don't have to have as big of a wheel, right? The less weight that the wheel must support, then the lighter your materials can be. We talked about how it could be safer in the event of a flat, and The benefit of this is it can straddle dead animals on the road. This is, of course, a hint to a story that I have to tell with my solar car. On the same testing on the same test that same year in '97, I was driving the car and we had a 3-wheel design, 2 up front, 1 in the back. And when you're first, if you're a teenager and you're driving, you get your driver's license, you learn a few things. And you go, okay, I'm in a car. If I hit a pothole or if there's some animal or things like that, all you do is split the middle, right? And it'll go right between the wheels, no problem. Well, in a 3-wheel design, that's not so great because you straddle right in the middle, and the rear wheel is typically right in the middle of the car. So if I straddle the two and say put the pothole right in the middle between the 2 front wheels, I will hit that pothole every single time. And in my test, that's exactly what I did. I was driving, I was straddling, and I would hit every single pothole on the road. And my team members on the radio are essentially counting how many times did I hit the pothole, and I probably had the prize for the most potholes hit. It was a good test of the back wheel, at least, right? But anyway, one of the things is that with regard to if you're designing for the new cruiser division, a 4-wheel design is required. It more simulates a solar car, and so something to be considering there. Now, the choice of wheel is important as well, because you have to be able to handle the weight of the car and the lateral forces from turning. So talking about each one, the weight of the car is fairly simple. The wheels tend to have specs. If you buy a pre-made wheel, there are specs to the amount of weight that it can hold, right? But the lateral forces is the issue. Let's talk about the choices, and I'll get back to the lateral forces. Some of the choices that you have, NGM wheels and tires, if you can still get them, are essentially machined aluminum wheels that are very, very light. And they take a tire that can take very high pressure. And so those are really good things because you decrease the weight of the car, you decrease the amount of contact point on the ground with friction, your car will go much faster or more efficiently with the same amount of power. However, they're very costly. And so it's something to consider. Now, most cars, especially entry-level cars, you'll get into a motorcycle, moped, junior dragster type of thing, which, if you think about a motorcycle wheel, and I'll show you a motorcycle wheel next, fairly hefty. It can take a lot of beating. They're just heavy. Bicycle tires are very tempting to use because they're very light, right? The problem with bicycle tires is that lateral force. If you think about riding a bicycle, all of the pressure, all of the force comes straight vertically on the axis of the wheel, right? And so when you're turning, you lean your bicycle and the pressure is still on the axis of that bicycle. If you're gonna capture 4 or 3 wheels with bicycle wheels, your car doesn't lean, right? Your car is going to sit on the ground, which means you start introducing some lateral pressures on that bicycle wheel for which it is not designed for. And so any users of a bicycle wheel should be very careful to go and not, to essentially overbuild the bicycle wheel or overspec a bicycle wheel so that you can make sure that it can handle those lateral forces. So here's some examples for you. On the left is a motorcycle wheel. It's a pretty hefty piece, and a lot of people like that. And then, of course, you have a bicycle wheel. And this is a possible type of bicycle wheel where you get a bit more of a structure instead of having just some set of spokes that are there in a very light aluminum frame. Here, I think it's more of a hub type of scenario. And so be very careful in the types of wheels that you select so that you don't get any breakdowns in your car. Let's talk a bit about brakes. I don't have too much to talk about in terms of brakes. I would say that we require 2 independent braking systems that allows you to stop safely. That independent braking system is essentially saying the entire, call it the brake chain, right? From the pedal actuator to your master cylinder to all the linkages, all the, if you're doing hydraulics, the hydraulics, all the way to the calipers, all have to be independent of one another. So you're going to have 2 sets of everything. Most cars do use these hydraulic disc brakes, and in particular, a lot of cars like this MCP brakes. What's neat about these MCP brakes, and we're not recommending you use any particular brake type, but the characteristics of this is that it's spring-loaded, which means if you think about a regular car brake, as you do your disc brakes and you engage them, the brake pedal stays, the brake rotor, the pads stay engaged until your car wheel moves forward, and sort of the friction of that moves the calipers and the brake pads back, right? So you're going to have a set of drag. If you buy something that has a spring-loaded pad, that would essentially, when you finish engaging the brake, it will back it off for you, and so you don't have that initial drag to get the brakes away from the brake rotor. So that's a really good thing. Okay, and so this is an example of the MCP type hydraulic brakes that you'll see on a lot of our solar cars. We talked about brake pedals being independent and the entire chain of being independent, but we do allow for pedals to be linked together if each pedal can be independently operated if a linkage fails, right? We've had experiences where, a solar car, there's a lot of things in the cockpit. You could have some type of thing that gets put behind the brake pedal to stop it from actuating. That's one possibility. Or, if you're making your own brake pedals, sometimes they're not welded well, or if they're not mounted properly, and they get stuck. And so certainly you may want the ability to have both brakes, available to you when you engage the brake, so that you get full stopping power, but you have to put your brake pedals in a way where if one of them gets stuck, you can still operate the other one. We also do require foot brakes, and so that's something also to consider there. Did someone want to chime in? I guess not. Okay. So that's something to consider with regard to brakes and your brake pedal design is, how do you design it where you can get both brakes systems engaged, but if one fails, that you can still stop in the other one. When we look at how we test for the brakes, we test them statically and dynamically, meaning that we're going to test that your brakes can stop the car from moving from a stop, meaning it's got enough brake pressure that you can't push on the car when it's stopped and move forward, right? So that's our very basic test to start out with, just to see if you have enough braking power, right? That your brakes are appropriately configured and spec'd, that it can actually stop the car. Once we finish testing statically, we will test dynamically, which means that we're going to bring you up to a particular speed, and we're going to test that you can stop your solar car within an appropriate period of time, right? And so those are in the rules and in our scrutineering booklets. So take a look at those times for that. A lot of first-year cars have problem, applying sufficient brakes on their car. The considerations there primarily is that you've got issues with the weight of the car, and the heavier your car is, the more brakes you're going to need to have in order to stop that weight, to stop the momentum from going forward. The other thing is that a lot of teams can essentially spec a smaller brake than they really need. And they do that to save weight. And so you really want to be able to make sure you spec your brakes accordingly. The other thing I will bring up here is when you think about dual independent braking systems, I think a lot of cars consider putting their brakes up on the front so that they don't have to deal with braking the drive wheel, which especially for hub motors may be an issue. So a lot of teams will decide to put two brake calipers on the same disc, right? So that you have two pairs of brakes. Some initial teams think that two independent braking systems means one caliper on the right side and one caliper on the left. Of course, that's not allowed because you don't want to be able to just brake one side and then veer one direction or the other direction. But certainly, if you want to save the weight of another brake rotor, you can mount essentially two sets of brake calipers on each of those brake rotors on the front wheel. And so those are something to consider there. So this is sort of a very quick overview of some considerations that you want to have as you build your car. We will get into more details of how you do that in the spring webinar series. But at some point, or I would like to open up for questions for a few minutes. And I have a few questions already. Where can we find this meeting recording? This recorded video will be edited and will be put on our YouTube channel shortly after webinar. So if you missed it, or if you have students that are looking for it afterwards, certainly you can go there. The other question that I got was, if you are a three-wheeler, can you add brakes to the back? And certainly you can. Certainly you can apply brakes to your back wheel. Some cars do that. They do that either via a drum brake or even a disc brake. You can do that. For those people using hub motors, they do recommend that you don't apply brakes on the drive wheel, and so teams don't tend to do that. But if you're not running a hub motor, certainly there are a lot of teams that add brakes on the back of the car. Any final questions with regard to this presentation? You can type them in the chat or the Q&A.
William, thank you for doing such a brilliant job on the presentation. We're going to expand on this as we get into our spring webinar series. I want to welcome you to our second in our webinar program, and I'm delighted to have an opportunity to have the caliber of presenters taking part in this. Our next speaker is a real treat for us. This is Q.C. Harris from Lockheed Martin. He's an aeronautics engineer, and he's in a very exciting program right now. He's in an engineering leadership development program, which gives him a chance to rotate through different portions of the company. He's worked with the NASA's X-59 quiet supersonic transport. He's been working with some flight control system simulators and currently working on software development for mid-air flight simulators so that a pilot flying an F-16 can actually consider what it's like flying some other kind of plane. So let me introduce you to Mr. Harris, and we're glad to have one of our sponsor representatives here today.
Thank you, Dr. Marks. I'm going to share my screen now. Okay. Okay, so thank you for that introduction. I really appreciate that. And it's an honor to be here to teach you about just learning from successes and failures based off of the experiences that I've had here as an engineer at Lockheed Martin. And so just to reiterate what Dr. Marks said about myself, I graduated from the University of Central Florida with my bachelor's in aerospace engineering. And I've been working at Lockheed Martin ever since 2017. And as part of Lockheed Martin, I'm part of the ELDP, what we call it, which is the Engineering Leadership Development Program. And it gives me an opportunity to see the full breadth of the company and all the different projects that we have, ranging from designing passenger jets for NASA to designing flight control computers for our legacy jets, such as the F-16 or the F-22 Raptor. And so I've gotten to see a lot of different like team methodologies and effective ways to actually achieve what we would like to accomplish, which is a successful aircraft or a successful product down the line. And so I want to come here and show you one of our key values in terms of designing and what we like to do to kind of drive our success throughout the company. And so today I plan on talking to you about how to actually approach success and failure and how to actually learn from our failures and our successes. But I wanted to take some time to familiarize you guys with how we as a company embrace failures. And so when I sat down and thought about how I can best describe how we at Lockheed Martin and at Skunkworks view and approach failures during our design processes, I felt like this quote from Michael Jordan explains our approach fairly well. And so the quote goes, I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot and I've missed. I failed over and over and over again in my life, and that is why I succeed. And this isn't far from how we approach failure as a company as a vital part of our success at Lockheed Martin. And so I wanted to just familiarize you guys with the importance of failure during our design phases, and then how we can go about learning from that failure and also our successes as well. And so at Lockheed Martin, we understand that one of the most vital moments during any design project, whether it's designing a supersonic passenger jet for NASA, or you are actually, here, let me change my slides here. Whether you're designing a jet for NASA or actually, one second, I am actually going to change the screen here. And so we understand one of the most vital moments during any project is when we come across failure. And so we have a culture where we embrace the failures that we encounter. And so there's an endless list of reasons why we would want to embrace the failures and embrace the cultures that we have in order to just go about approaching our failures. And so, for example, it gives us the best opportunity to learn during our design efforts. The entire design process is also a learning process. Even though we're looking to achieve a particular goal, what we want to do is actually learn during that process as well. Because the best puts us in the best position to succeed down the line. It also allows for us to safely design our air vehicles through rapid prototyping. And so this gives us the best opportunity to design a lot of different configurations or a lot of different ideas. It allows us for us to explore a lot of different inputs throughout the team rapidly throughout our design process. And then it also gives us the opportunity to push the boundaries of our designs based off of our lessons learned. And so it allows for us to actually just push our thinking of what is acceptable and what is achievable throughout our design process. And so whether it's on a team of engineers designing an air vehicle or an athlete training to compete for an Olympic medal, the failures that they come across on their journey is just as important, if not more important, than the successes that they achieve. But when you do encounter that failure, what is the best way to actually learn from that? And so what I want to do is come here and actually show you the strategies that we use as our company and with our team, within our teams, to learn how can you learn as much as you can from that specific failure. So I want to introduce you to three key strategies that I use with my teams at Lockheed Martin to learn from those failures and to put you in the best position to design not just your solar cars, but with all of your engineering projects in the future. And so one of the key methodologies, one of the key ways in order to approach our failures is to reward one another for reporting the failures or successes equally. And so you want to create a culture where you are comfortable with reporting failures to one another throughout your team. This allows for you to actually see the failures successfully and also to approach the potential vital lessons that you're going to get as you're approaching those failures. The second key strategy that we like to employ when approaching our failures is to try and replicate what happened, whether it's a success or a failure. If you've conducted a key test and you've achieved a success, that's great, but can you do it again? Because if you can do that again, then it gives you key information in terms of how you can go about that down the line. And then you want to approach all of your successes and failures as learning opportunities and not just roadblocks or achievements throughout your design process. And so I'm going to go into detail about each key strategy in a second. And so one of the key strategies for approaching failures is creating a culture where it's okay to fail, not deliberately and not down the line when you have a product that is finished and you have a life on the line. But you want to create a culture where it's actually okay to fail during the aspects of your design processes. And so as engineers and team members and contributors to any design, especially with the production of your solar car, somewhere along the line, you're going to make a mistake, whether it's a small miscalculation or something much bigger. And the quickest way for your team to get to the bottom of what actually happened is to start off by being able to say comfortably, hey, I've encountered a failure, this is what happened. And so when you create a culture when you can easily get to that point, that gives you the most amount of time in order to figure out how can I actually go through and amend this failure down the line. You want to create that comfort within one another to have that, because if someone is not quite comfortable with reporting those failures or actually just approaching the team with saying, hey, this is what I've come across, then you're going to lose that vital information down the line. And so it's good to approach your failures with what happened and not who did this. And so I can say that within our teams at Lockheed Martin, we have a lot of fairly high stakes projects. And so we have a lot of roles that gives us an opportunity to either succeed or to fail. And so we have an opportunity to just show, hey, this is what I've done, this is what I've learned, instead of saying, I've either succeeded or I've failed. It's more of, this is what I've learned down the line. And so the second key strategy to approaching failures is to try and replicate what happened, whether it's a success or a failure. And so this is actually one of my core roles at Lockheed Martin. Whenever you're designing a new product, whether it be a system, a flight control computer, or software, you want to test that particular product. And you have a lot of high stakes tests. And throughout that testing process, you're going to come across a successful test or a failed test. And no matter what it is, either a success or a failure, if you come across a failure, you'll say, good, can you do it again? Or a success, you'll say, good, can you do it again? For example, we were testing a flight control computer for an F-16 roughly a few months ago, and there was just an anomaly with testing. Just the pilot was doing an input, and the aircraft was not doing what should have happened. And so we were able to replicate that. And in replicating that, that gave us vital information on how we can go through and figure out like what was the source of that anomaly, apart from whatever our testing was happening at the time. And so within that test, we learned vital information. We took as many notes as possible, and we collected as many variables as possible during that success and that failure at the time. And so when we were able to replicate that failure, we were able to just go ahead and do that amend, and then actually just control the variables, control the notes that we took, and then lead to that success after the fact. And so another way that we can approach these failures through replication is to take whatever success or failure that we encountered and replicate it in a virtual environment. So that can be a simulator, that can be a model or a calculation. And whether you have calculations for whatever you're designing, or code for whatever you're designing, sometimes it provides a safer option to replicate whatever you're doing in that alternative environment, because A, it gives you more information in that you can actually confirm that this failure is part of the system itself, part of the system design, and we can get towards figuring out how to amend that, and it's not for a less technical term, a fluke. And so identifying that puts you in the best position to approach, the failure in that process, and then also just best position yourself to succeed down the line. And so we at Lockheed Martin, what we want to do and what we always try to do is to have the mentality that failure is always a learning opportunity. And success is also always a learning opportunity. And when we have that mentality of failure and success being an opportunity and not just a roadblock or an achievement down the line, then we're able to approach failures in a more, what we call an intelligent matter, basically. And so when you approach failure as an opportunity to learn while you're on that path to success, then what you can actually do is have the mentality to sit down and think, okay, what can we learn from this? Okay, what are we learning from this? What am I learning about this particular system I didn't know before? And so those are actually some of the most crucial moments on that path to success. And so during that path to success, you're also going to have a lot of successful tests. You're going to, test some sort of component. You're going to actually just test certain things down the line. And maybe the test goes perfectly, maybe it goes somewhat perfectly, but you actually have achieved that objective. Maybe it doesn't go well at all. Throughout all three of those different scenarios, you have vital information that would help you towards your end goal. And we try to have that particular mentality when we're going about our approach to both failures and successes throughout that design process. And so that was my take on the three key strategies that we employ at Lockheed Martin, and that's going to work throughout my projects, and how we approach failures, and the culture that we've built throughout our company to actually just have an intelligent mindset towards failures down the line. And I want to wish you guys best of luck, and happy failing. And I'll turn it back over to Dr. Marks.
Mr. Harris, I want to thank you for your input. One of the things that you stress is the importance of testing. And this is one of the things we talked about last week in our last workshop when we said that teams should not come to the race unless they put about 500 miles on their solar car. If it's going to break, let it break at home, not at the race. And the three
Absolutely
didn't qualify last time. The three teams had not tested their car before they arrived. So you stress a very important point, and thank you for a brilliant presentation. Our next
thank you.
speaker for our workshop today is Joel Pitts, who's the advisor to the famous Greenville High School solar car team. Mr. Pitts has worked with us for a number of years and has done a great job launching 2 different levels of solar cars in the last couple of sessions of the Solar Car Challenge racing event. So let me turn this over to Joel and give him a chance to tell you about how to find parts for building the solar car. And at the end of his presentation, I hope he will introduce you to the Greenville solar car team.
Yeah, thank you. Let me go ahead and share my screen. Let's see here. Okay. Okay. Hopefully everybody can see this. So one of the hardest things to do is, where do you find parts when you're going to build a solar car? There's no kit, which is I think one of the best parts about solar car is your students really have to go out there and find and figure out and how to put it together, how to make things work. I'm always a big proponent of, like, hey, we found this part. It doesn't work for this, but we can make it work for this. So one of the first things we'll start off with is, how are you going to power your car? So solar panels and how you're going to power your car is like a very important step, because there's a lot of different variations in panels. You have the ones that have glass hard weight. You're going to have flexible panels, and then you can also, if you're a little crazy, you can build your own. That's what we're doing this year. We're building our own array on a car that we'll show you in the shop later. But we're entering into the advanced division. We've done the classic and the electric solar, and our students are in the process of building an advanced car. Some of the places that have been great resources for us, and let me back up a little bit and say, I am by no means an expert. This is strictly from experience from our team doing research and finding where to buy parts. And also, we share any knowledge that we have gained with any team that wants to know. So at the end of this will be my email address. If you've got questions or want to ask me anything related to solar car, we're an open book. We want to see teams progress, and we want to see students learn no matter where they're from. So Wholesale Solar, this is a great company. They worked with us our first year. We bought some solar panels, and they also carry, later we get to it, other components for your solar charging unit. They actually helped us out with shipping, so they were able to belay the shipping, so we didn't have to pay for that. Yes. SBM Solar, they are a company out, I believe, North Carolina. They will build custom solar panels. I know a number of teams have had that done. Liberty Christian, Covenant Christian, New York. We've ordered custom panels from them. They'll make them. They're thin. They have a little bit of flex to them, not a lot, but they're thin. They're a little bit lighter. They don't have the glass on them, and they can build them to what your specifications are. So if you call them up and say, I've got this square area that we're working on our car, they'll help you try to find a variation of panels that will work for what you're trying to configure. Civic Solar is another company that carry certain solar panels. We went with them because they were the only one that carried a Panasonic brand that we wanted, but I wanted to just go ahead and include them as well. SunPower supplies solar cells for other manufacturers that want to implement those in the panels. you can also buy these cells individually from them. What is unique about the SunPower cell, rather than the ones you've seen, the monocrystal that are real flimsy and not very flexible, they'll break easily, is on the back of these cells, they have a solid copper backing, and they're very flexible. If you see in the picture there, you can see somebody bending them. On their website, they have a special pricing for education. So it's going to be, it's dramatically different pricing. They'll actually help you out on shipping. But if you're gonna attempt to build your own solar panel, I don't recommend it if you're a first-year team. I don't even recommend it if you're a second-year team, unless you've got people or mentors that are there that have expertise in this. There's some challenges in it, because you got to remember, if you're going to build that, every single spot that's soldered, you need to have like 5 people coming behind them and doing quality control, because your entire race hinges on your solar array lasting the all 4 days. But the efficiency on these cells are pretty high, which would limit you to probably the advanced division or the new cruiser class. One of the other important things, so once you get the power from your panels, you need to be able to convert that to charge whatever size battery pack that you choose to have. And so in order to do that, this is the most important part of your charging setup, is you're going to have a multi-point power tracker, also known as MPPT power tracker or charge controller. And some of the popular ones for first-year teams are Outback and Midnight Solar. In the picture on the left, Midnight Solar, that is a great charge controller. And the company, man, they are fantastic. They have fantastic customer service. You can call them; they'll talk to you. One year when we about the second year into it, we were using this. Another team was using it as well, and they sent one of their lead engineers out to the solar car race to see how we were using them. If you're running a 48-volt system, this can easily handle everything you're going to throw at it to convert it for a 48-volt system. These are good up to 72 volts. If you go higher than 72 volts, you're going to need to transition into a little bit more expensive and a little bit less user-friendly version of a charge controller. And that would be, this one right here is a Aerial, they're out of Australia, charge controller. It is not user-friendly. To use the technical terminology that their customer service gave us is like, well, you just need to fiddle with it to get it to where you want it to charge. And that's pretty accurate. So they are expensive. The Aerials cost around, with shipping and all, you're talking about $1,000 to $1,200, depending on what the exchange rate is with Australian dollar to US dollar. The Outbacks and the Midnight Solars, they're anywhere between, if you catch them on sale, between $700 to $800. And then you also have Gensun. I don't have a picture of them in here, but Gensun makes controllers that handle for doing 48 volt pretty well. They're very inexpensive, so you could buy extras in case one of them goes out. You have easy replacements. The Nomura. So Nomura is out of Japan, and they supply parts for a lot of teams in the World Solar Car Challenge. We were researching their product line, because eventually we're looking at, once our advanced car is built, is to possibly buying their motor. But we're also looking at their PowerPoint trackers, and they have a very unique design setup. If you go to facebook.com/Nomura and send them a chat message, just wait, because the time change is a little different. If you want to know like what they have, they'll send you a catalog of their stuff through the mail. There's a little bit of a language barrier there, unless somebody on your team speaks Japanese. They're pretty good. They travel all over the world working with all different companies, and but they have very unique charge controllers. You can see that, the size of it. They put a cigarette next to it to show kind of how big it was, and then they've got a coin kind of showing the width. So the deal with these, you would need a bunch of them. So it kind of works out to about the same price as buying these versus these, but it just depends on what your team is trying to achieve. One of the newest, quote unquote newest, charge controllers that are out there is a former world solar car racer. His name's Elmar. I can't remember his first name, but he just started designing his own charge controller specifically for solar car racing. And I went ahead and added that link this year because we went and researched them. But these are pretty user friendly. They also have a communication port on them. You have to learn how to use CAN bus. But if you got some students that are pretty heady in like computer programming, I don't think it would be that big a deal for them. CAN bus is what all the communications and all the vehicles you're driving now use. These are right here probably the most expensive ones on the market right now. But if you ever go and you've done research looking at world solar cars and you've done to the different pages and looked, these are the ones that they're using. So this is an important decision. So make sure that you do the research and you understand, is this power tracker going to fulfill the need that we need for our vehicle? Okay, because if you don't use this correctly and it doesn't communicate and charge the voltage that you need for your batteries, then your car is not going to be as successful as you'd like it to be. So then going into batteries. So you have the solar panels, you got your charge controller, and now you have your batteries. Batteries is another huge decision. Depending on how you pick your batteries will determine like the weight of your vehicle, a significant portion of the weight of your vehicle. These are some places where we purchased our batteries. Battery Guys, man, great website. It's free shipping. Okay, so when you go and you look at Battery Guys, they do it for free shipping. And I don't know how they do it because the price of their batteries is right on the money with the other places, but the other places charge shipping. So we've ordered our batteries for the last few years from Battery Guys. We use primarily sun extender batteries, but we've used Energizer and what was the other one? Interstate batteries. They all work pretty well. We've had really good luck with sun extender. They're pretty rugged batteries. I included the sun extender website so that you can go in there and research the different type of batteries. Battery Space, they have turnkey lithium battery systems. So if you're wanting to run a lithium battery system, if you're going to be in the cruiser class or the advanced class, you can go on there and they have like every type of battery you can think of, they're going to have on there, but they also have the lithium battery systems that have not only the batteries put together in the amperages, the amp hours you may want, but they're also going to have the battery protection system or the battery management system, which is super important because you need to manage those batteries that's required in the rules so that you're not drawing a lithium battery down too far or you're overcharging it. So that kind of makes things a little easier because we've run into some hiccups on battery management systems where we bought them from China and we've bought 2 or 3 of them because it's really hard. The customer service is difficult. Being able to talk to somebody and explain exactly your problem and having that communication barrier is there. Although there are some cheap ones on eBay you can purchase. PowerSonic is another good battery manufacturer, DCbattery.com, and then Wholesale Solar. Wholesale Solar can be kind of a one-stop shop for you if you want to do that. The other thing about Wholesale Solar, they were very accommodating as far as filling out the paperwork to become a vendor for our high school. So that could be an advantage for you. Let's see here. Okay, motors and controllers. You've got brushed motors, brushless motors, and you got hub motors and chain drive motors. If you're going to be in advanced or the cruiser class, and you can use a hub motor where you just attach the wheel and there's no chain or gearing involved. But if you're in the other classes, classic, advanced classic, or the electric vehicle class, then you're going to be running an inexpensive chain drive, permanent or brushless motor. Cloud Electric has a variety of all these motors. They don't have hub motors, but they have a variety of the standard electric motor that most solar cars use, and they're going to have they have the largest variety of motor controllers I've ever seen. They're a big supplier for, I'm gonna let that bell finish. They're a big supplier for forklifts and other battery operated warehouse equipment, but they carry a lot of the stuff that we use in solar cars. That was one of the first places we purchased our motors from when we started. Electric Motorsport, great website, great source to get your motors and controllers. EV drives as well. Thunderstruck, those three right there. They have a lot of the stuff you're gonna need, because like Thunderstruck's gonna have your motor controller, your motor. They're going to have fuses that you're going to need for it. Throttles. They'll have all different varieties of throttles for applying acceleration and then communicating to the controller for that. Some of them, they're starting to have a little bit of heads-up displays that are supposed to be coming out to where you have like a digital display in the car that'll give you like all the things that the motor's doing. I know that last time I talked to Alltrax, they're working on a heads-up display, because a lot of people have these sport buggies now. It's kind of like a cross between a golf cart and a UTV, or an all-terrain vehicle. So they're working on some kind of heads-up display, because people like to tweak them, play with them, and change things out. So hopefully that'll come out. I can see that being important for people racing cars. Switches and disconnects, lights, fuses, and wires. Oh, you know what? Let me go back. I missed one that I wanted to talk about. Mitsuba Motors. Talked about them with the MPPT. The Mitsuba motor, that is the hub motor, quote unquote, to get right now that's available. They are pricey. You're going to spend anywhere between Covenant Christian. I think they're the ones that have bought one recently. They would be somebody, Shannon Caraway. He would give you some straight up knowledge on that. I want to say that they spent somewhere between $16,000 to $18,000 for the motor, because you also need to buy wheels, because they make custom wheels for them. But it was somewhere around that for that motor, and they have great customer service, and you can actually send it back and they'll refurbish it between your years of racing or whenever you feel like it needs to be done. And they'll kind of work with you on price depending on what they have. So that's a good company to contact. Again, that's through Facebook. Switches, disconnects. This is just a list of different places that we've purchased these kind of items through, depending on how creative you're getting with how you want your driver to interact with the driving compartment of the vehicle, and what kind of, and access for switches and different things of that nature. You may have different needs. Source and fuses, that got a lot easier with the rule change, so that you don't have to just have a fast blow anymore. You can have a slow blow. So let's see here. Technology, Electric Motorsport, Mauser is a great resource. DigiKey is a great resource. Again, EV drives, like I said before, they carry a lot of this stuff. Kimball Midwest, you can order a catalog from them. They'll send it to you for free. There's going to be a local salesman. The only thing with Kimball Midwest, they can be a little expensive because they don't put their prices in the catalog. You have to talk to the salesman. So it may be a little bit like dealing with Dunder Mifflin, if anybody catches that joke. But they have a lot of awesome parts in Kimball Midwest. I don't have it on here, but I'm just going to put it out right now. They have a set of drill bits. Will drill through grade 8 steel like butter. They're expensive, but they're awesome. Brake lights and turn signals. You've got, you can go to O'Reilly's and get brake lights. Granger carries for the ECCO lights. These are lights that you especially have to have if you're going to participate in a cross-country trip, so they can be mounted on your trailer in the vehicles. E-trailer is another place for brake lights. Fuses, you can get fuses from the same places I named up at the top. There's a couple of new ones on there. You got Waytech, McMaster Car, and then wiring. My recommendation, this is my recommendation, and like I tell my students, you can take my recommendation and file it in file 13, because this is just my advice. I don't want to tell anybody what they should use. I just want to say from our experience. Your main wiring going to from your motor to your controller and your batteries. I highly suggest that you source welding cable. Welding cable is designed for really high amperage use. It's going to be better than standard battery cable you would find in your vehicle. You got to think that battery cable in your car, it's designed to be like the main cable going to your starter. It's designed to be used in short bursts, not constant usage at high amperage. Welding cable is designed for constant use at high amperage. And there's amperage charts out there that you can pull to make sure that you're getting the correct wiring for your application. The lower voltage that's used on your vehicle, the larger the diameter or the larger the gauge of wire you're going to need so that your vehicle is going to be safe and handle the amps that you're going to push to the motor. All right. And again, Cloud Electric Motorsports, and EV Drives, they carry the correct size gauge wire that you're going to need for your vehicle. All right. Some of the stuff that you'll need in your vehicle, a speedometer. You need to be able to do a minimum speed. I know on a road race, you have to do at least 15 miles an hour. If you drop below that, you have to pull over to the side and charge, or you have to trailer the vehicle. So knowing what your speed is important. Low voltage alarm. You have to have a low voltage alarm for your auxiliary battery so they can tell you if it's getting low so that you can switch it out. You don't want to have your blinkers or your horn or emergency lights fail on you so that you don't have that, so you can notify other vehicles what's going on. That would be a bad thing. Speedometers, speedhut.com and eBay. The last few times that we've purchased them off of eBay, and you can get a GPS speedometer. It doesn't require you to do any kind of magnet and pickup at the back wheel. You just plug it in, make sure your GPS antenna can hook up to the satellite, and they're super accurate. And they're kind of cool looking. Also, 12 volt technology. So 12volttechnology.com has fantastic, they have battery chargers and monitors, but they also have the low voltage alarms built in that shows you what your voltage is, and then it has an audible alarm that goes off with flashing light in the same holes where the alarm's coming out. Rig Runner is this fuse box. We have found that having this pre-purchased fuse box that we can run wires to, and you'll notice that each one has its own isolated positive and ground, because you can't use the frame on the solar car as a ground. Everything has to be isolated from the frame. This solved a lot of issues for us. So we had issues where we would have you're going to have that little minor bleed over just from EMP from the wiring going along. You may strap it to the frame. You have that little 0.0 whatever, which everybody kind of has that. But if you have like full 12 volts to the frame, because the wiring wasn't the best, this fuse box, it's a little pricey. It's like around 150 bucks. This solved all of our problems with that. It also made the wiring extremely clean. And here's one of the benefits. You have a fuse for each one of your systems. If you have a ground to frame issue, you can isolate it really quickly by just unplugging each one, plugging it in. And as soon as it pops up on your meter, you've isolated the system. Previous stuff that we've built, it was all just kind of wired up into a little hub, and we weren't sure where the problem was. This allows you to isolate it very quickly if something was to happen. Usually we're trying to minimize having to work on the car at all when we get to the race. But we have had a ground to frame issue before, and this allowed us to fix it and get everything working within 20 minutes. Prior to this, we had a whole day to where I was worried we weren't going to pass because it was taking 4 hours to track down the ground to frame. So this is a suggestion. I feel like this is like one of the best things we've ever purchased when it came to doing the auxiliary electrical system. Volts and amp meters. It's really important to know what your volts are for your battery and how many amps you're using. You can purchase volts and amp meters off of eBay or Amazon relatively cheap. I would suggest if you're going to buy them, don't buy just the ones you need, buy extra. The one in the picture here, that's about $6 to $8. It's really inexpensive. And so we usually buy, 10 at a time, because invariably you'll have a student hooking something up, or you'll have the teacher messing with it and they'll blow it out, because I mean, that kind of stuff happens. I'm not saying I've done it, but I've done it. All right. Sprockets, seats, seat belts, brakes, and steering. Custom sprockets. There is rocketsprockets.net. They'll make custom sprockets. Rebel Gears. We've ordered our sprockets from Rebel Gears. It's roughly around $150 for a custom sprocket. Just know that once you request your custom sprocket, and once you pay for it, you own it. There's no returning them, because they're one-off customs. It's really easy to know you're getting the right sprocket if you've got a motorcycle rear wheel and swing arm. You know what it came from. You know what the wheel is, so they're going to have that in their system to make the sprocket for you. But knowing which sprocket you're going to use and playing around with that once your car's built and you start testing, having the right gear ratio can help you tremendously on your efficiency for your vehicle. Super Sprox, I found those guys, but I haven't used them. We've used Rebel Gears. They're pretty good. Seat belts, Summit Racing, and Jegs, motivational tubing. All these are great. You can actually go buy your seat belts at your local O'Reilly's or AutoZone. They'll order them for you. So you can source those there. Brakes, MCP, which is Martin Custom Products. These are fantastic brakes. They come in, you have different sizes. Like if your car's heavier, they have a bigger size so that you can stop. If your car's lighter, you can go down to a smaller size. They supply a ton of brakes for college teams. And I talked to the gentleman on the phone. I forgot his name, but he was very, very accommodating, and he helped us. We were having trouble bleeding them, and he helped us out on what technique we needed to use. And they're really good brakes. We've also used the brakes, motorcycle brakes on our vehicle. Those work great too. The advantage to the MCP brakes, if you're looking at the picture on my presentation, you'll see that there's two silver circles at either end of that brake. It allows you to adjust the brake so that when you let off the brake, they're not touching the rotor. So in solar car, the less friction you have, the more efficient your car is going to be. There's a book called The Winning Solar Car, and in there it talks about 80% of the power of moving the vehicle is from friction. So that's real important. Let's see here. Motivational tubing, they carry brakes. They carry braided brake lines of all different lengths and all the different connections so you can make things work. Chassis shop, and then AliExpress. I'll talk about ordering stuff from China here in a couple of slides, but AliExpress can be a place to source stuff. Steering, motivational tubing. You can have a steering kit that look like here that works. Sometimes that works, sometimes it doesn't. But they're also going to carry rack and pinions. Chassis shop carries that, Go Sports, and then AliExpress. But you can also get your seats through Jeg Summit Racing. And I do recommend using a race seat, because you know it's going to be constructed to protect your student. Okay, suspension, wheels, metal, nuts, bolts, and parts. ATV, like our cars, ATV arm suspension works pretty good. Now, just remember that if you're going to use this, if you're going to use those components off the vehicle, you have to design the frame yourself and then attach those components. You can't just chop the front off of a four-wheeler and weld it onto a frame. You have to make it to where you're involved in the design process on that. But ATV, that stuff works great. Chassis shop sells upper and lower A arms. You can modify in different spindles. Shocks, you can use Fox shocks. There's a number of really good shocks on eBay. On our electric solar vehicle, we ended up getting some pretty good shocks off of eBay for a fraction of the price of Fox shocks. It's just one of those things you got to really research and look for what you need for your vehicle. Metal for construction, online metals. Online metals is a great resource. They're expensive if you purchase from them, but it's a great resource for you to go on there because online metals is going to tell you how much the metal weighs per foot. You can select it for outside diameter and inside diameter, so your thickness. And that'll tell you how much it is per foot if you're really paying attention to how much stuff weighs. It'll also give you information so that if you're dealing with a local metal supplier, you've already researched it on online metals. And so you can kind of speak with a little bit of knowledge to them so they can understand what you want to get. I included a company that's low, it's kind of out, it's here in Hunt County outside the Metroplex, but it's called QMF Steel. They are the ones that that sources a lot of the specialty metal in this area for like chromoly, different grades of aluminum. You can get titanium through them if you're going to go that route. Just a number of any specialty metals that you would need to get your hands on. QMF Steel has that. Garland Steel is pretty good. And then wixaircraft.com. I would suggest this because I know that not everybody, people from all over the United States, start researching your local area. Go to your local metal supply and say, hey, do you guys do chromoly? Chances are, if they don't, they're going to know who you need to talk to. Go talk to them and then start building those relationships because chromoly is expensive. And if you can build a relationship to maybe a partial sponsorship or them help you out on shipping, that can go a long ways for other components on your vehicle. Nuts and bolts. McMaster Car is great for especially nuts and bolts. Kimball Midwest, great. Again, they don't have prices in there, so you don't know until you talk to the salesman. But I will tell you this, boltdepot.com. After our second year of scrutineering with kids putting in the wrong bolts for mock-up on our vehicle, I just decided to go ahead and buy all grade 8 bolts. If we mock it up, if we prototype it, they're using a grade 8 bolt. And the reason for that is if they forget to change them out, it's not a big deal. It's already got a grade 8 bolt in there. They are the cheapest. You can go in there and order what you want, and it's the cheapest. I had a local supplier here. He says, I think I can get them cheaper. He could not. But Bolt Depot is a great resource for bolts. If you're going to order bolts, order more than you need and bring them with you to scrutineering, because what you're going to find out is if you get there and you're short on a bolt and another team doesn't have it, and you go into town to your local tractor supply or hardware store, chances are the bolt that you need is the one everybody else team needs, and they're out at the store. So we've had that happen too. Wheels, Summit Racing, our electric solar, we use weld wheels. They're race cars. We have an AT front end, and then we use wheel adapters. So we go from ATV to automotive, and that allows us to adapt the weld wheels onto the vehicle. You can also use, we use moped wheels on our advanced vehicle for the front. This website called treatlandtv.tv, they are a moped supplier of parts, used and new, out of California. They're up around San Francisco. I will tell you this, if you email them, if they don't get back to you right away, be patient. I really, after talking to the guy, he had that classic like Spicoli accent, if you've seen Fast Times at Richmond High. And I think that they run their moped business to support their surfing habit. They're super nice. They're great on the prices. Customer service is great when you can talk to them. Just be patient. They have a lot of good stuff there, and a lot of stuff you can't find anywhere else if you want to deal with like a moped wheel. AdapterKings.com is where you can get adapters if you want to go from ATV to a certain automotive wheel, or you're going back and forth, and they will make custom adapters if you're needing to go from a 4-bolt to a 5-bolt or vice versa, or anything of that nature. So that's a great resource. Composite materials. If you are going to jump into the world of composite materials to make things in your car lighter, these are some websites that we are using right now. Express Composites, ACP Composites. They sell like Kevlar and carbon fiber pre-made panels which are super light. So I know some teams use that for their floors in their cars. They're strong and light. You can eliminate some weight. It's just this stuff, when you get into this, it starts getting expensive. Rockwest Composites is another one. So far, I found that ACP is one of the more quote unquote affordable in the composite market when you're trying to get components. Shrink wrap. So shrink wrap is one that a number of teams have used. We use it to form the body on our car, and basically it comes in big rolls like you see in the picture, and all it is shipping wrap. It's what big 18-wheelers use to weatherize their equipment on a flatbed to ship it across the United States if it doesn't want to get rained on. It's super inexpensive. A whole roll that's like 200 feet long. It's 200 feet long and it folds out to 20 feet wide. A whole roll costs you like $295, and you can get the shipping tape that goes with it. And if you do your crush zone like we have, so earlier when William was talking about the car that was white, we made our crush zone and also incorporated crush zone into the shape of our car to give it aerodynamics. And so we skin it with the heat shrink, and once it's on there, they sell a heat shrink gun that's like $700, but and it runs on propane. But a regular Wagner heat gun from Home Depot, AutoZone, or whatever gives you way more control, and it works really well. If you make a mistake, you can take it off and put another piece on. Putting bodies on our car was a wonder for if you have the luxury to do that. Did wonders from our team as far as drawing more students in, because they're like, oh, it looks really cool. But if you're interested in that or you have more questions about it, you feel free to contact me. This last one on here, it's the foam Elliott Company. I put that on there. If anybody's going to dip their toe into making any composite parts, a lot of times you need to make a plug before you make a mold, and that's usually made out of foam or styrofoam. And you can, if you have a router at your school, or if you just do it in the computer and you know what your layers need to be and what the dimensions, you can cut those out and form a 3D shape and then come back and do the sculpting on it. There's been a few schools that have done that. So if you're interested in composite materials, if there's something that's not here, I'm available to talk to. One-stop shopping. If any of your schools are like mine, Amazon is now a vendor for us. So I can go on here and drop stuff into a cart and order things off of Amazon, and they get to us pretty quickly. That's going to be a great resource for getting things. eBay can be a little harder, because if you are a public school, you're kind of thinking, well, how do I purchase off of eBay when eBay is not a approved vendor? I'll talk about that here in a minute. And then also Walmart. Walmart.com carries a lot of stuff that's not in the store, and I'm sure a lot of y'all know that. But they carry, lathes, all kinds of different kinds of tools. So there may be something on there that's not on the other one that you're trying to source out that may be there. So that's a great resource. Ordering from China. Okay, so if you're going to order something from China, just expect extended shipping time. We ordered a front end that's on our electric solar car, and it took 3 months to get to us. You don't know what's happening at the different ports of call where they're unloading and loading stuff, so just expect extended shipping time. And then if you get the part in, it could have incomplete parts, so you may be stuck with trying to manufacture something for that part. There's a communication barrier. There's no warranty. Even if they offer a warranty, it can be very difficult to get the warranty honored. So just keep that in mind when you order from China. Order at your own risk. Discounts. I've kind of said this before. Ask if they would be willing to sponsor the part or partially sponsor parts. Ask for free shipping, because a lot of times when they understand what you're doing, and if you have any promotional material set up for your team already, you can always include that in an email once you start fostering some kind of relationship. Approved vendors. So this is where I'm going to kind of talk about, this is more so for public schools. Private schools have a little bit more flexibility, I believe, but if you become a 501c3 for your team, private booster club, then you have more flexibility. But if you're a private school, this is one of the workarounds that has worked wonders for us. And I think that I'm counting on saving our team about $40,000 since we've been doing it. If you build a relationship with a locally owned business, so we built a relationship with a locally owned CarQuest dealership for auto parts. And Randy, he owns it. And we went and approached him. We said, hey, we would like you to be a sponsor for our team. We don't want you to give any money. Would you be willing to purchase things off the internet for us with no markup? And he said, absolutely. Now, the key is that, we'll order stuff and it might be $5,000 to $10,000. And so the way it works with a public school is when you purchase stuff, the vendor doesn't get paid until the school receives the product. So Randy's sticking his neck out there, and he's got money floating out. But he's done that for us, so that's allowed us to order stuff from Australia, China, any website, any place, anywhere. He'll go in and order it with no markup to us, and then when it comes in, we just fill out the invoice, and then he gets paid. That right there will solve a lot of issues as far as being able to source a part, because the red tape with the way that the vendors work with the public school, you could be working a month to get one part in. But if you have somebody that's already an approved vendor that owns their own business and is willing to be your to intercede for you and do this, that can save you a lot of time. You can get stuff right off the bat, and that way your project moves forward. Please feel free to email me with any questions. If you have any now, you can ask. I'll put my email up there. This will be added later where you can pull this up and watch it again. And then my email's there. Just if you have a question, email me. I'm an open book. Our team's an open book, and we'd be happy to answer any questions or help you try to source something. Let me stop sharing this real quick. Okay. I'm going to kind of pick my computer up and walk out to the shop. The students have been working on stuff, and we're going to let them introduce themselves and show you our vehicles, and if you have any questions about those. Oh, I didn't put my mask on. Give me 1 second.
While Joel is walking, if there are particular parts of the car that you're interested in seeing, you're willing to show you that, just go ahead and type that in the chat or in the Q&A, and we'll make sure that they know you're interested in that part of the car.
Okay, so we're going to try to do this. I'm going to switch cameras to the handheld camera and see if this works. All right.
Great.
Let's get so Corbin is our captain, and this is our shop. Let's see here. I need somebody to hold this. Who can be the camera person? There we go. All right. So Corbin, go ahead and introduce the team, and then show them, like, kind of go and show them the cars, and then I'll tell you if there's any questions or anything.
So we're live in Greenville, Texas. We've been here since 2012. We're working on our 4th car currently. It's all new to us. We're starting with the mold, the plug here. You want to change the camera? We've made this all, it's all styrofoam with drywall mud, putty, cleaned out, and then sanded out to get it smooth like glass, basically. After you get from there, you go on to the mold of it. So this is our top half with the bubble where all the panels go.
Switch. All right, we're switching real quick. All right.
So this will be our top half here with the bubble where our head's going to go and where we're going to sit at. And then this is the bottom half here. This is where all your, you can get it. All right.
So what we have here is the bottom mold for our new car called Invictus. This will be the car that we're going to be running for our advanced division this year for the track race. And so what we have laid down right here, so this is the roll cage that we're going to be using for our new car. We kind of have it laid down. Right now we're making the marks for it, making sure where our roll bar is going to go, where all the things are going to line up at, and how the driver's going to sit in comparison to how we have everything headed out and get out. And that's pretty much it for this car. And so this is the bottom mold, and all of our carbon fiber is going to be laid down on here. And us, like all of our students and the team, are going to apply the process of putting all the carbon fiber down, applying it, drying it, putting it in a vacuum sealed bag, and making sure everything's nice and solid.
Okay. You want to go on to, I'm doing it, you ready? Yep. So what division is this vehicle, Jordan?
This is Regulus, and it's in the electric solar division. This is our electric solar division car, Regulus, and we're not doing much new to this car this year because we're really focusing on Invictus. But right now we're working on the brakes because we were having some problems with that once you guys got out of the shop. And
We'll try to do a little kind of a walk around. It's kind of difficult. Let me see the computer real quick. This is all new to us. We're trying to figure out how to do this to show the car in the camera. You can kind of see the front. Hey, close the hood real quick so that let me see if I can get a shot off at the back here. All right, so this is kind of a shot from the front. It's really hard to see because they're in the process of getting it ready. They're trying to get this car finished before the holiday, so we don't have to worry about it, and then we can focus on the other. Yeah, so this is the heat shrink that I was talking about that we use to wrap the vehicle to give it some aerodynamics. If there's any questions that pop up, if somebody could let us know, we'd be happy to answer those. It's kind of hard to see in there. We're going to go out to the other vehicle. Who wants to describe this one?
So this right here, when this car was first made, this started out as a classic division car, with the 48-volt battery pack and all of that. And this past, not this past year, but 2 years ago at the track race, this car was converted into an advanced division car, so we could get the feel of how to run an advanced division car, testing out our 96-volt battery pack, testing out our new motor, our hub motor that we had installed in our car, and then testing out to see how we could all apply that into making a brand new car. And yeah, so that's basically the overview of that car.
Okay, pull the hood back so we can give them a shot of the inside.
So this right here, this is where our driver sits, and this is kind of like our roll bar that we had added onto here, the little halos right here with the personal fans. And down here is where the driver's legs will go. We have our throttle mounted down there, and we also have our brakes. And this right here, this screen added onto our steering wheel allows us to see our voltage and amperage as we're driving the car, so we can radio back in between the pit, and we can radio to the driver to get a better and accurate voltage and amperage of our car, and know how to run our car for strategy. We'll go to the other side.
You want to open that up?
Is the other side
Oh, it's a snap here. Here, open this up.
So right here, you'll get a good look inside of our car, and this is where we have all of our battery boxes, our BMS and everything, and we can get a good look at our battery pack when we take this off right here. So this is a 96-volt battery pack that we had built to test our new batteries, and the students here, we built these cells in a little like capsules right here just to see and get a feel of how everything's gonna go in our new car. And then if you look back here, you can see our motor controller, our fans, and how all of our battery box is built and everything. And then you can get a good view of our suspension system in the back. And then we can show them the motor.
There's the the power trackers. All right, let's see here.
And if you look back here, we actually had these rims right here. We have these machined specifically to fit onto to be able to hook up this motor onto our wheels. So this motor is mounted onto the swing arm, and then it's bolted right here onto the motor.
Now, who designed those wheels?
We actually designed these wheels on CAD. We use SolidWorks. That's the CAD industry that we use to design these wheels and have them machined.
And then we built a relationship with the local machine shop to machine those. They kind of fit them in, but we asked him what it would cost to have those machined, and he said about $750 a piece, and that didn't count the motorcycle blank that we purchased for them to machine those out. But if you can't find the wheel that you want, you can design it and have it machined. Let's see here. And then if you notice on this vehicle, we just have standard solar panels that you know, the ones that have the glass on them. You just find the ones that are going to fit your budget and what you want for your car. Is there anything specific that anybody out there wants to know or get a closer look at? Let's see. See, I tell you what, why don't y'all go ahead and take that wrap up and off? Is it easier on the other side?
Yeah.
Yes. So this is our EV car. This is kind of a quick overview of how all of our systems set up. So the gearing that we have on this car, our ratio is based on, like, it's perfectly in the middle to where it's not geared necessarily for more torque, and it's not geared for more speed. It's that right gearing you want right in the middle, to where it helps you going up those hills, but you also get a good speed coming down the hills.
Okay, so it looks like we got a question. They want to know how much does each car weigh? Corbin,
Yes, sir.
how much does this, do we remember how much this vehicle weighs, the electric solar one?
Ooh, we're sitting right at
We had bets going on what the weight was when we weighed it. Do you remember what it was?
850.
With the drivers in it.
With drivers, and they try to 850.
With the drivers in the vehicle, I think they said it's like close to 850 to 900. So that would put it probably around 650.
650 curb weight.
I think, yeah, he said 650 curb weight on this one. And then what do we think it was on the one outside?
That's 700, 800.
700 to 800 pounds. I would probably say it's closer to 800 pounds.
Then our new one would be right at 400.
Yeah, the new one, which you saw the mold for, their goal is to do it right at around, the goal is 400. You know, you have to set a goal. You can also see on this one, this is an inexpensive motor. It's all chain drive. That is a all-tracks controller, same ones you find on golf carts. And then I'm gonna see if I can get over here. Give me 1 second. That's a custom sprocket, and so we already know that what this wheel came off on a motorcycle. You have a custom sprocket, and then you've got sprockets up there on the motor, and that's just a rear swing arm off of a motorcycle. It's off of a CBR 250. It's a Honda. Up here, that is the swing arm off of our very first car from 2012 and 2013. We've got it stored up there. But you can build your complete rear end and have it where you can put it on and take it off. Is there any other questions or anything? If you have any, email us. We'll be happy to send pictures or share anything else that we have as far as knowledge. All that. I'm gonna
Joel,
switch.
can you hear me?
Yeah.
I want to thank you and the Greenville High School Solar Car team for doing a marvelous job sharing with us about the parts and where to find them, and then taking us out to your shop and seeing what's going on. I really appreciate that. And I know a lot of the new teams feel a little bit better having a chance to see other students doing this. So you have appreciation on this. I'd like to inform our webinar visitors that we're going to be doing a third webinar on November the 21st. That's going to involve electrical engineering and the importance of telemetry and data gathering. While you're here, Joe, what do you do to gather your data so that your planning team can help advise your driver?
Right now, you know what? I didn't even include it. I may send it as a supplemental. We found another company out of California that provides a BMS. It's called Nuvation Energy, and they're U.S. based, and that's huge for us because we have good customer service. But they deal in battery management systems all the way up to 1,200 volts DC. So we called them. They said they could do it and set us up for our about 100 volt car, and they actually were able to provide us. One of the engineers there kind of geeked out on what we were doing. He says, "Hey, well, here's what you can do," and he said he would mentor our students where we can use a Raspberry Pi and a screen in order to gather the information from the battery management system to tell us what our car is doing. In the past, we have built a Raspberry Pi system or an Arduino system that collects your data from the motor, what you're using, how much is left in your batteries, how much you have coming from the solar panels. The Midnight Solar, I will tell you this, on the MPPT, it's got a removable screen, and you can remove that and move it up into the compartment with you, and it will tell you what you have coming in, and it will tell you what you have at your batteries. So those two things, what you have going out and what you have coming in, is really important. If you don't have anything else, you've got a driver or a co-driver that can radio you that information from the meters you put in your car. And again, I can expound on this. I can have students expand on it. If anybody wants to contact us at a later date and have more probing or in-depth questions, we are an open book. We'll share everything that you know.
Thank you for being willing to share things. This goes so nicely with our first webinar when we're talking about our philosophy is that we are not a competition, but we are a sharing type of organization where if you've got something, you're going to share with somebody else. I appreciate that, and you represent this finely. I want to thank everybody for participating in this. Thank you, presenters. Thank you, Mr. Harris. Thank you, Mr. Shee. Thank you, Mr. Pitts. Appreciate it. And most importantly, thank you, Greenville High School Solar Car team, for being there on Saturday morning. I hope you have a great day.